I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Cozy edition.
Cozy
Just
edition.
kidding.
Yeah.
For those of you who are watching on YouTube, you can see I'm wrapped up in a little blanket, all cozy on the couch today.
Yeah, and we are in a general sense, ever since we moved to or added in YouTube, we did literally move over to the couch. Mm-hmm. So there's a general coziness that is new to the show.
Yeah.
So.
It almost feels a little bit more like we're just friends chatting.
Yeah.
Instead of being at a desk, that felt a little more teachery.
I wonder if there has been a notable difference that comes through on the audio side. It's like, they sound cozier.
I can hear their coziness.
If anyone's not seen that we actually changed settings a bit, but it's a little more comfy than a desk, which is kind of nice.
It is. It's definitely nice.
Yeah.
Okay. Guess what, Jam?
What is it?
I'm really excited about today's episode. And
really?
I know I'm always excited. And people are like, you got to pick a new word. You're always excited about everything. But that's just how chemistry makes me feel. Well, it just excited is the best word.
I'm thrilled to find out what it is.
Thrilled. Okay, well, I just think it's really exciting. I'm going to go all in on it. Okay. But you actually already heard this question because many of you know Jam and I go to church together.
Yep.
And we did a big meal to celebrate Easter. And while we were sitting at that meal, like in our church, a friend of ours, she's also a woman in STEM.
Yep.
And she came up and said, listen, why does shaking milk make butter?
Right.
And like, why milk specifically? Why don't other things do that?
Right.
And I was really excited about that question. And then later that day, one of our other friends left a little bowl with some butter in it and a little butter knife. And I was playing with the butter. It was so satisfying. And I just kept thinking, what is this?
Yeah.
What is this that I'm like spreading with this knife around? So it's a question from our listener and friend Clarissa, but also it just took root in me and was one of those that I was like, yeah.
That is pretty cool, especially because I was just sitting there when it happened.
Yeah.
Like a lot of the questions or ideas that come in are things that I may also see too if they came through one of our like email or whatever website. And I may just see them pass by at some point and I have no idea when Melissa might pick it up and use that one or what she's planning next. But it is odd that just only a few short days ago, I heard this question get asked right next to Melissa, and then here we are recording it now.
Yeah, now we're recording it. So that's fun.
I'm very interested.
Coincidence.
I'm excited to find out.
Did you have any thoughts when she asked that question about what it could be? And listeners, y'all can also take a minute to think about what it could be.
Yeah, I know that there's a lot of fat in milk.
Mm-hmm.
And that we talked about back a long time ago, butter and margarine, and about the structure of it, and something about the fat is able to kind of combine in a structure where it becomes solid.
Yeah.
If it's given the right conditions and that kind of stuff, and that you have to do some fancy stuff to get oil to do the same thing.
Yes.
In the case of trying to make a butter substitute or whatever. So that's somewhere in my brain still, a little bit of that.
That's impressive. That's still in your brain.
And then I have seen videos of people making butter. And I've thought, I don't want to do that. But I watched the video anyway because I was like, this is interesting. But it wasn't someone who could explain exactly what was happening.
How did they make the butter?
They, I think they put it in a stand mixer and had a specific attachment to it.
Yeah.
I
don't know if you need a specific attachment.
Oh, I don't know anything about that. I don't know what's a normal attachment, but they had something attached to it so they could mix it up and sort of churn it in that way instead of like a old.
Once I accidentally made butter when I was trying to make something else. I'll tell you that story at the end. You have a good understanding of that.
But that's all I kind of know. And also, my thought is, I wonder if there's fat in milk. What else is in there? Like, what's the other stuff?
Guess what? We're going to talk about that
too.
Cool. Some of our listeners probably have done this, so I want to bring it up. There's also an experiment that a lot of little kids will do, where you put cream in a jar and shake it up, and that also will make butter.
Okay, interesting.
Just a little bit. It's more similar to the churning method,
Yeah.
So that's also a way that people make butter that I saw on the internet when I was doing this research. And I'm guessing a lot of our listeners have done that, or, in like elementary school, or, depending on, you can do that at a lot of different ages, depending on what concepts you want to pull out.
Here's a question I have too, and maybe you'll answer it on our way. But if you're wanting to make butter at home, do you have to get like whole milk, or can you do lower fat milk, or does that make it way harder because a lot of fat's gone?
Yeah, so I'll talk about milk here and what happens to milk. But really, you want whole milk from the cows, like straight from the cow, not whole milk that you see at the store, but like raw milk, I guess is a better way.
Okay.
Or heavy cream, or double cream is sometimes called in Europe.
Okay.
So we'll talk more about that.
Okay.
That's a good question.
I definitely have bought heavy whipping cream for various recipes and stuff like that.
Yeah.
So I'm guessing that has way more fat in it.
Mm-hmm.
Got it. Okay.
Okay. So good job. You have a lot of this already in your brain. So that's really exciting. Okay, so before we talk about butter, like you asked about what else is in milk, we have to talk about milk.
Okay.
So raw milk from a cow is made up of fats, proteins, minerals, vitamins type of thing, water, and sugar, also known as lactose.
Okay.
Okay, so something that should stand out to you is that there's fat and water.
Yes.
Do those things mix together?
Normally, no.
Normally, no. But sometimes they do. And so the reason they normally don't is because of intermolecular forces.
Right.
It's the return of intermolecular forces yet again. And a quick overview of intermolecular forces. We go a lot more in depth on this in other episodes, even actually the margarine versus butter episode, the second one we ever did. But essentially, intermolecular forces are literally the forces that act between molecules to attract them to each other. So it's not as strong as like a bond, but it's definitely not nothing. So sometimes molecules are drawn to one another.
Mm-hmm.
And in one of the things we talked about is there's the intermolecular forces of sort of like is attracted to like. So
right.
If the electrons are evenly distributed around a molecule, there's not a positive area or a negative area. They're all kind of neutral.
Mm-hmm.
That can attract to other molecules that are similar with dispersion forces.
Right.
So I think if the electrons are evenly dispersed, then dispersion forces bring them together. But if they're unevenly distributed, sometimes you'll get a concentration of electrons in one area and a lack of electrons in another area, making one area negative and another area positive, causing sort of poles like in magnets.
Right.
And the negative side of one molecule is strongly attracted to the positive side of another.
Right.
So it's just easier for those two to interact with each other. That's called dipole-dipole, or for dispersion forces to interact, on nonpolar molecules.
Okay.
So that's why we get this thing that happens where if you mix water and oil together, or fat and water, or you'll have the nonpolar molecules finding each other really easily and the water finding each other really easily, and they don't really want to interact because it's just easier, I guess, to interact with itself is a good way to think of it. Okay.
So water, polar, and oil/fat, non-polar.
Yes.
Okay.
And in our very first episode about soap, we talked about how soap has a non-polar side and a polar side, and it can kind of bring them together.
Right. And actually allow them to interact where otherwise they would basically avoid interacting. Okay.
Mm-hmm.
Right.
But milk, is sort of special because you have the fat distributed in it and you have water in it. I mean, the major component of milk is water. And the thing that brings them together is actually proteins. So the protein in the milk, for some reason, acts as a really good agent to bring fat and water together.
Okay.
And there's a name for this type of agent. You've probably heard about it before. It's called an emulsifier.
Oh, yes. Okay.
Or an emulsifying agent.
Okay.
And so milk proteins are able to make milk be essentially an emulsion, where all this fat and the proteins and the vitamins, everything is sort of evenly distributed in the milk, not separated out in oil and water layers. Okay, but here's something fun that I love. So I was like, why? Why do milk proteins do this? And I always love when the answer is we don't know, but it seems like that's the answer is we don't know. So I found a paper that's recent as 2019 that stated that little is known about why. Let me make sure I got this right. Little is known about the detailed physics and molecular mechanisms of milk emulsions, which is so exciting to me.
Dang, interesting.
So the detailed physics and molecular mechanisms of milk emulsions isn't well known.
Wow.
And I'm guessing that there's something in the proteins that's nonpolar on one side and polar on the other. But if it was that simple to identify that, I think it would have happened already.
Right.
So I'm curious about why there's so little known.
Yeah.
So that's exciting.
It's one of those great scenarios where nature is doing something super cool that it's been doing forever.
Yeah.
And it's like we figured out, so probably by accident, but still it was a human like effort of like, oh, we figured out this plant or this whatever. When we do this thing, it's able to like get, say the early humans were trying to get some animal fat off of their pan.
Yeah.
They figured out if I do this thing, it actually gets
with
it off.
With this plant, yeah. I remember our friend Vianette, who's also on the show, sending us some indigenous people. I don't remember where she was visiting, but the indigenous people in that land used a plant.
Yeah.
To basically make soap.
Yeah. And so it's like, it's already occurred, but we figured out how to combine the things. In this case, it's like, oh, nature has been making fat and water work together with this protein, and we call it milk. And it's been around forever. It's like, that's just so crazy.
It's so crazy. The other thing that's interesting that is important also is if you zoom into the molecular level, the fat isn't like individual molecules of fat. They're sort of grouped together in little globules.
Okay.
And it seems like there's maybe a slight membrane around the globules that sort of keep them together.
Okay.
So maybe that has something to do with how the protein works as well. But essentially, milk is just water with a bunch of other things dispersed in it evenly in an emulsion.
Okay, wow.
Nice.
Interesting.
And that's called let me make sure I get it right. I think it's called a fat in liquid emulsion because the fat is distributed in the liquid.
Got it. Okay.
Or maybe fat in water.
Right.
So now what does that have to do with the butter? So
seems like nothing. Seems like unrelated random trivia to me.
Yeah, definitely. I'm well known for doing that.
Yeah, thanks for those fun facts, Melissa, but I just don't get how we're going to get to butter from here.
Well, you actually kind of got it already because essentially butter is just undoing that emulsion and getting the fat together.
Mm.
And you basically said that there's fat in butter and that there's fat in milk, so they must have something to do with each other. That's essentially right.
Okay.
What we're doing is putting energy in by shaking up or using a stand mixer or whatever. We're putting energy into this body of molecules, meaning that the molecules can move around more and more and it's getting agitated. And sometimes that energy may even break the membrane around the globules, which would allow the fat to leak out into the rest of the milk. And as it's being agitated more and more, the molecules are moving more and more, which gives them a higher chance to interact with other fat molecules. And because there's more fat molecule interaction, it's easier for them to interact with each other than the water. So when they find each other, they're going to cling on to each other, making larger and larger globules or accumulations of fat, which eventually become visible to our eyes.
Okay.
And that is butter.
Interesting.
I know.
Wow.
So literally you're just basically putting energy in to overcome that emulsion and provide the opportunity for fat molecules to meet each other and hang out together.
Yeah.
With those intermolecular forces, they'll be drawn to one another.
Yeah. Wow.
And so that's like a quick overview.
Okay.
But I think it's important to talk about the fact that butter it's like kind of easy to be like, okay, so that's what butter is. Butter is milk fat, and we just separate out the milk fat by letting it interact with each other. That's it. But it is a lot more complicated than that. And I don't think that that's worth kind of diving into on the show, but I just want to underline that The chemistry of butter is pretty complicated. So, according to a 2021 paper, at the molecular level, butter is made up of a continuous liquid fat phase. So there's still liquid fat in there. It's not all solid at room temperature.
Mm-hmm.
It has a crystalline network of fat, which it's not just, slammed together. They do crystallize as they meet each other, similar to the way snowflakes do. There's like a nucleation site, and then they kind of grow out from there.
Mm-hmm.
So there's an underlying crystal structure that makes butter spreadable and nice the way it is. If you've ever melted butter and resolidified it, you know it's different the second time. There's water within the fat still. It's not completely devoid of water, so there's a dispersed water phase. There's intact fat globules and fat globules that have, lost their membrane.
Mm-hmm.
There's air, and essentially it's still an emulsion. It's just what we know as a phase inversion. So the fat in water emulsion switched to be there's water now distributed in fat. So it's still got fat and water combined as one thing, but instead of it being combined in the liquid form, the water is distributed in the solid form, where the major thing is fat.
Right.
When before the major thing was the water.
Got it. Okay.
And that's known as a phase inversion. That's like more complicated chemistry. I would say that's more in polymer chemistry range. And even the membranes around the fat globules, I think, would go into like surface. There's like a type of chemistry that looks at sort of the interface between different either liquids or things like that.
Yeah.
So that's really, all of that is really complicated chemistry. And it has to have this nice structure so that it's solid but still spreadable. And there's tons of different fats in there that, some are saturated and some are unsaturated. So there's just all kinds of stuff going on in butter. And I'm giving you the eagle eye view, but there is much more complicated stuff going on if you want to zoom in on butter. So
it has mysteries. It's still holding on to many other things that are going on that are cool.
Yeah.
But the main chemistry of how we get from kind of milk to butter is what we covered in detail.
And we talked about, you asked about milk straight from the cow versus, whole milk.
Yeah.
So then I was wondering about that same thing. Like when we're talking about milk and all of these resources that I'm finding about butter, what milk are we talking about?
Yeah.
So then I found Michigan State Extension, which they've done work that we've used before.
Mm-hmm.
And an extension is a part of a university which takes scientific information or information about maybe like agriculture and distributes it to the public or farmers, people who need to use it.
Got it.
And if you want to learn more about that, you can listen to our episode about the sea level rising, because my sister, the other Dr. Collini, was on for that.
Yeah.
And she worked in extension, although I think she's accepted a new position, maybe at a different thing that's not quite extension anymore,
Nice.
But still.
Yeah. The episode's cool, super cool. And she does explain extension in detail. I'd never heard of that until she talked about it. Or you'd probably told me, but she explained it in a way that I was like, oh, okay.
And it's really helpful. Like I use extension a lot of times if I'm not finding good science that I'm confident about, like, if, the American Chemical Society hasn't really done anything. That kind of happened this time where there would be really basic information, but not more in-depth stuff that I was looking for or things that weren't from a good, reputable source. So I just typed in extension butter, and then I found from the Michigan State Extension. I was really excited.
Oh, cool.
So they, I've linked to it in our show notes, but they talked about what happens when milk goes to a plant, sort of to be processed.
Mm-hmm.
So that raw milk has enough fat in it that I think you could use that to make butter.
Okay.
I'm assuming that's what was done previously.
Mm-hmm.
But the way that milk is processed now, it's separated out into 1%, 2%. It's standardized based on fat content. And the extra fat from that is skimmed off, that floats to the top or whatever. And the excess fat is made into cream or is used to make things like butter.
Right.
So for us, I think you would need to use heavy cream. You could maybe use whole milk, but there's just so much less fat in there that I think it would be really difficult to have enough that would even make those globules happen,
Yeah. Or I watched, one of the videos I watched, there just was, the person said, I think they probably were using some sort of heavy cream, but But they said there's always some leftover liquid, which is probably mostly water, and maybe some globules you couldn't break up.
And protein and probably vitamins and stuff. Yeah.
All the other stuff. But there's always something left, which kind of makes sense because you're going to try to do the, what'd you call it, inversion?
The phase inversion.
Phase inversion. Mm-hmm. And try to make a situation where there's a lot more fat, but there's water in that.
Yes.
You are probably going to have some leftover water.
Yeah. If you didn't have water left over, it would have been butter to start with.
Yeah. Yeah. And so anyway, they talked about you need to get rid of that and kind of pat it and dry it off and stuff like that. But it seemed like maybe if you did use whole milk, you might just have a ton of leftover water.
Yeah.
And lactose and all the other stuff in there. And maybe you only get a little bit of butter and it might be kind of wasteful in that sense. Yeah.
That's what I think.
That'd be kind of interesting to see like a comparison of like, yeah, you can make butter with all of these, but look how much yield you get. Like, you could do 1%. And it's like, look at this little bit of butter.
Yeah.
You could get 2%. Whole bone.
You like spend hours trying to make it work.
Yeah. That'd be interesting.
Like, this is a visualization of the fat content in this milk.
Yeah. That's cool.
That is cool. That's fun to think about. Okay, so that's a good overview of milk to butter chemistry. Mm-hmm. If you want to explain it back to me, then I'll give you some fun facts.
Okay.
That include the time I accidentally made butter and also some other fun facts.
Okay, deal. I have an analogy that's working in my head a little bit. We'll see if it works out loud about how milk becomes better.
Okay.
So when I was in high school, before I was the co-host of America's #1 chemistry podcast, at humble beginnings in student council. And I was the student council, I was a member and then treasurer and then president my senior year.
Nice.
And so that meant I was going to student council. We had these, I guess, I can't remember if we called them convention or what it was called, where the student councils from our whole city got together twice a year for some thing. I just can't remember what they called it. But so all these schools got together, all the student council leadership and stuff like that went to these. And one of the things they always did, we always spent the first bit of time basically trying to shake up the fact that you have people from all these different schools coming together that are, of course, they're going to be kind of stuck to each other, right?
Yes, yeah.
And so that's their most comfortable state at the moment, and they come that way. That's like the globule kind of thing I was thinking. And so what they do is they had multiple, not just one, multiple icebreaker type of games that weren't just like break the ice, get you to talk, but literally getting you to move around.
Get up and move around in your, like away from your seats.
Yes.
Okay.
And so there was things like, one game was called like Amoeba and you're moving around. Another one was like I think a kind of a version of rock, paper, scissors, something like that.
Oh, like where everybody cheers.
Yes.
That's a fun one.
And there are other ones where like you had to find certain people that had, like, I remember one of them was they kind of had some questions out there and you had to find somebody who had the same answer to the question as you. So something like, this is not perfect, but something like you had to find someone who's the same favorite color as you.
Okay.
Something like that.
Or the same, like the youngest kid.
Yes.
The youngest sibling, or the same number of siblings.
Yep. Yeah. Same birthday month. Stuff like that. There are things you had to do to find someone like you, meeting certain criteria or whatever. But what that makes you think of is like the globules, they're already existing in that state. But if you can disrupt them some and create some conditions, they will try to find someone like themselves.
Yes.
That's not necessarily in the current state that they're in or the group that they're in or connected to the protein that they're currently connected to and stuff like that. And so if you can do that by agitating the milk up and mixing things up and kind of breaking things up, the fat will start to find itself and other fat and grow into a group of that being like.
Yes.
And then the water likewise will stay together and want to be with itself.
Yep.
And if you keep doing that enough, if you had a lot of time, you can get to a kind of maximum of the most like or here in these two groups, so to speak, in the case of milk. And trying to make butter out of it. And that's what it reminds me of. You had to really put some effort into agitating the groups of people in the student council situation around and really break it all up.
Yeah.
Get them out of their little groups. And then you were able to actually create potential for them to find each other meeting totally different criteria.
In this case, I'm going to say that the milk, like the water and the proteins in the milk, is awkwardness.
There we go.
So
nice.
the awkwardness is separating us all and keeping us in our little groups, all the little student councils separate. And then as you shake it up, then the awkwardness leaves and the people start to find each other and form connections. So it's one big unit of student council group.
Yes. And then there's always a few folks who are resistant to the fun and the icebreaker and the unity of the group. And those are the people of the water. Who knows? Those
are the fat molecules that get left behind.
Yeah. Every analogy breaks down at some point. But yeah, does that kind of make sense?
Yeah, I think that's a really good one. The only thing I want is...
Oh, wait. Let me say real quick.
Oh, okay.
I obviously I'm leaving some chemistry on the table.
Yes, so that's what I was going to say. I want some more chemistry.
Yeah. So to get more detailed, the fat is nonpolar. So there's an even distribution of electrons in the fat molecules, which means that if given the opportunity, they will be friendly with and connect closely with in dispersion forces with other fat molecules and hang out together. There still is water and stuff like that in there, like you mentioned.
Yes.
But it just is a higher concentration of the fat if they can get a chance to get together.
Yeah.
Water polar, where there's a heavier concentration of electrons on one part of the molecule than the other.
Yeah. And
that side is very attracted to the less negative, meaning positive, side of other water molecules.
Yes.
And so that makes them want to hang out together, and where the negatives and the positives can link up and stay in close quarters and not let a lot of things in between them if possible. And just by doing the agitation thing, we allow that natural desire of those different types of intermolecular forces to find each other more and more, even if it's not completely 100% pure and perfect.
Yeah.
It creates obviously a visual difference for us. You can see the fat of the butter start to form and come together, even though there's still some water in there or whatever.
Also, like, how much is really pure in life that's good and tasty?
Totally.
Not a lot.
Yeah.
So it's okay that there's still water in the butter.
Yeah, I mean, in the case of like spreadability and whatever other else, it's probably all good that it has the mixture of things it has.
Yeah.
You know?
Well, and there is some of the studies that I ended up citing that talked about some of the content of butter. They're looking at how does heat treatment before or after, like how does this impact the spreadability or the crystal formation or the crystal structure of the butter. So there's a lot to learn about butter.
Yeah. I was just the other night, Em and I were hanging out with listener and friend of the show, Joey.
Oh, yeah.
And his wife, Kristen.
Don't they have a cute dog named Maple?
They do have a cute dog named Maple.
Yeah.
Yes.
I'm a big fan of Maple.
Yeah, she's very cute. And they were talking about how one of them, Kristen, can't have dairy. And so they're talking about the different things they have to do to substitute for cooking and stuff like that. But what they're talking about was like, it's actually kind of amazing how easy butter is to change out. We figured that out for such a long time ago, you know? And like, that was back to the older episode. But so many things are so hard.
Yeah.
But when you think about it, really it's kind of mind-blowing. Like butter's complicated and really confusing and interesting and amazing. And the fact that we're actually able to replicate it close enough, just for our taste buds, not for like, you know, everything molecularly, but like for our taste buds, is actually kind of mind-blowing.
Yeah. It is not surprising to me, though, that initially they kind of messed it up with all the trans fats.
Right.
That doesn't surprise me too much.
Yeah.
But they have better alternatives now without trans fats in them even. And I think they have some naturally occurring like plant fats that are solid and stuff.
Yeah. I've seen some, I don't know if this is where this would land, but I've seen some butter substitutes that are like a good amount of it is olive oil. And so it's like not just some lab thing, but it's a very common and relatively healthy type of oil that's being used there. And that's a good chunk of what's making it up. But on the like taste side, it is kind of impressive. Like so many things are hard to do without dairy.
Yeah.
And like you have to just work hard to figure it out or change up recipes. But butter is like, no, it's easy.
Yeah. They did it. They figured it out.
Yeah. Go science.
Well, on that note, I'll have two things. One, the episode that we're going to release again, our re-release, is going to be the trans fats. What are they, and are they evil?
Nice. Okay.
Because it goes so well with this topic about trans fats, saturated fats, unsaturated fats.
Uh-huh.
So if you want to learn more about the pitfalls and joys of hydrogenating oil and making it solid, you can listen to that one next week.
Nice.
But also, I have a fun fact about canola oil that I found.
Okay, sweet.
So just as a very quick overview, saturated fats usually are, they don't have any, they have some, saturated fats have no double bonds. They have all the hydrogens that they possibly can, so they're solid at room temperature. But unsaturated fats have double bonds in them, and some are more desirable than others. Okay, so canola oil has been promoted because it has low saturated fat, which is good.
Mm-hmm.
And canola oil is actually the oil of the rapeseed plant.
Mm-hmm.
But I was like, so why is it called canola oil? Well, originally it wasn't edible because it had a high acid content. And so it was used for a lot of other things like lubrication and industry and stuff. But some conventional breeding techniques, they were able to reduce the acid content, and they made this edible version of rapeseed oil. Uh-huh. And they called it canola oil because it's Canadian oil with low acid content.
Oh my gosh.
So CAN from Canadian, O from oil, low L, and acid A.
Wow.
Canola. I know.
That's so interesting.
I know. I was like, technically, this is a butter episode, not an oil episode. But we're going to talk about oil on the re-release episode anyway. And so this is a fun fact to get you excited about it.
Totally. Yeah. We've used canola oil quite a bit. And I had read some things about it being like relatively good. And I know there's a lot of debates about that stuff, so I'm not trying to get into it. But we just switched from something else that probably was less good. But somehow that never came up. Like I knew it was from the rapeseed plant and stuff, but I never knew why it was called that.
Or even wondered.
Yeah, totally. Yep. I mean, it just seems like, probably normal. Probably fine.
It was just in one of my textbooks. It was just like a little aside in one of my textbooks. I was like, This is amazing. Okay, so I was really excited about that.
I love that.
The other fun facts I was going to tell you is we've talked about butyric acid before. I have a lot of fun facts, so buckle in. But the main chemistry is over.
Yeah.
And we've talked about butyric acid before. It's in blue cheese. It's in American chocolate. And I thought it was butyric acid because it has 4 carbons. So like butanone or butane is like how butane is how that's usually said. So the acid name of that, the proper chemistry name, is called butanoic acid. So I just figured that's why it was called butyric acid. Wrong. Butyric acid is one of the bad smells that we get from butter going rancid. And butyrum is the Latin word for butter. So that's why it's called butyric acid, not because of butane at all.
Wow. Interesting.
I know. So that's 2 crazy name things that I found out.
Yeah.
They also used to use a butter yellow dye. Here's another margarine failing. I mean, it's impressive that they were able to make butter substitutes, but they used a dye called butter yellow dye, but was known to be carcinogenic, and it's not permitted anymore.
Okay. Yeah.
So just another example of sometimes new technology is amazing, but they sometimes don't do great.
Yeah.
Like we didn't need it to be yellow.
Right. And I get that the bigwig marketing folks were like, it's got to be yellow.
Yeah.
And initially it probably did need to be, but not the expense of people's health.
Nope, definitely not.
On the carcinogenic side and on the trans fat side and all that stuff.
And then the last fun fact I have for you is I have this chocolate raspberry cake that I make.
Uh-huh.
You've had it before.
Yes.
And there's a mousse layer in there.
Uh-huh.
And that mousse layer is whipped cream mixed with mascarpone cheese.
Okay, yes.
And you're supposed to use a hand beater. But I got a new stand mixer, so I was like, I'll use my stand mixer. And it'll go so much faster. And I just used the whip attachment because I thought the whip will be good for the whipped cream in there.
Totally.
No, it curdled, which means the fat started to clump together and made butter out of the fat from the mascarpone cheese and the whipped cream. And it already had chocolate in it. because it was like, okay. And then I added chocolate and then it curdled and then I was trying to save it and I was just making it worse and worse.
Oh,
and
no.
Eventually I just gave up and I took out this chocolate butter that I had made.
Wow.
And I had to just make a buttercream frosting out of that instead, which was not as good, but was fine. But left behind was those like milk solids or milk liquid with the chocolate in there. And it was like some of the best chocolate milk I've ever had.
Oh, that's interesting.
I know. I was like, is this the best chocolate milk I've ever had? Because just basically like water and chocolate. Yeah. But so one time that did happen to me where I made chocolate butter on accident.
That is so interesting.
But the cake was still good.
That's good. Good.
So those are all my fun butter facts for you.
It's so funny too because I probably would have made the same mistake. I'd be like, whip attachment. Yeah, this will whip it. Great.
Yeah.
You know?
Great.
But it did it too good.
It did it to the point where it became butter.
Yeah.
And that's really made me wonder, when that happened, I had this thought and then I haven't really revisited it until now, is would just regular old butter, like should we just make our own butter? Like I have a stand mixer.
Right.
Would that be cheaper, tastier, maybe even healthier? I don't know.
A good question. I wonder if it would be a little bit cheaper, but you'd wonder about the amount of effort.
I don't think there would be that much if you have a stand mixer. Right. I mean, then I made that chocolate butter real easy.
Yeah.
I turned my back and then it was butter.
Yeah. I was thinking like compared to the amount of effort, compared to the fact that butter is not very expensive.
But you know what? Heavy whipping cream goes bad in my fridge somewhat often because I'll buy it for a cake and then forget about it.
Right. So maybe if you have some extra.
Yes.
And if you just make the butter when you do have extra.
Yeah.
Then it won't go to waste.
Yeah.
That's a good idea. I was thinking like the scale you might have to make the butter at to really make it worth it and feel like you're actually saving enough money.
Yeah.
Might be like, oh, it's not saving that much
like
money.
Making butter for cake, that's not probably a good idea.
Yeah. It's like I could just go buy a box of 4 sticks of butter. Takes me 10 minutes. Mm-hmm. And it doesn't cost a lot.
Yeah.
I'd need to, the scale that the dairy industry has to do this in a way that's really profitable for them and works great for them. I don't have the scale. To do that. So me buying enough heavy whipping cream to make this much butter and take an hour to do it, or maybe it's 30 minutes.
I think it's less. Yeah. You just pour it in and I think pretty much ignore it.
Yeah.
You just let it go until it's butter.
Yeah. I just think like, it might not be worth it.
Might not be worth it. Yeah. But would probably be worth it if you're trying to not let your heavy whipping cream go bad.
Totally. Yeah.
Like once I finish a cake, instead of being like, maybe I'll use this again later, I should just give it up and I've already got the stand mixer out and pour it in and whip it up into some homemade butter.
And if you do it, you should definitely take some videos and pictures.
Okay, I will. And also you could add rosemary in there. I don't know what. It sounded like I was going to say raspberry. Yeah. You could make like a rosemary butter.
Yeah.
That'd be good.
That would be good.
And people would be so impressed. And you're like, this was an accident.
Yeah.
This was leftovers.
Yeah. You leftover with a cream.
And you really can do that in like mason jars. There's a lot of like experiments online where they'll have kids just shake up a mason jar with cream and make butter.
That's cool.
Which is a fun experiment that they get to eat after. Yeah. A lot of times you don't get to do that. So.
Yeah. Lots of it's frowned upon, you know?
Great. Well, that's all I have for you today. Is there anything fun you want to share, or do we have time for that, or would you rather just wrap it up here since we had so many fun facts?
Let's do really short ones. And the thing I'll say is just sort of an addendum that it was cool that I got to, Em and I this past weekend got to hang out with Joey and Kristen.
Oh, yeah.
I mentioned earlier. They came over. We hadn't hung out with them in a while, I think since they got married in October. Mm-hmm. And so that was really enjoyable and fun to get to hang with them. And you know, the kids have changed a lot since they saw them last, which it's always like, you don't really realize that as often as whenever someone's like, oh, last time I saw them, they were only doing blah, blah, blah. Yeah. Or whatever. And so
that even happens like once a week when I see them. I'm like, last time I saw you, you were not saying this word.
Yeah. Yeah. And so that's been really fun. And then we got to eat some delicious Thai food. There's a handful of places that they love and that they don't obviously get to have when they're not here. And so we got to get some Thai food and enjoy that together. So that was just a fun highlight of the week.
Nice.
Yeah. What about you?
Well, I'll addendum on mine too. We had our Easter celebration, and I think my friend who's from Ghana didn't know this. So for other people who don't celebrate this way, a lot of times what we'll do is have what we call Easter egg hunts for Easter. And so we'll hide eggs around in the yard or whatever. It's not too hard usually for kids to find. And then they go try to find the eggs, and inside the plastic eggs there's treats, which when you explain it to someone who's never seen it before, it does seem kind of wild.
Right.
But we put that on as a church. So some people in our church organized that, and it was really fun. I got to walk around with Jam's son and a few other kids. And I just got to hang out with the kids more than I normally do. They were like in the room with us the whole time during the meal and stuff. And there's a few of my really close friends' kids hang out in that group. And so it was really fun to get to see them experience for the first time, really, the wonder of an Easter egg hunt.
Yeah.
At one point, your son picked up a rock and put it in his pocket, which allowed the younger children time to catch up to his egg gathering.
Oh, yeah.
And another point, a train came by, and he did not care about the eggs at all.
Yep. It also helps that he's had a few hunts this year.
Yeah.
And so it's good for him to let the other kids have their time to shine.
I did try to point his direction further away because he's the biggest kid. Yeah. And it was like, oh, go over here while they get these easy pickings. But it was really cute.
Yeah.
So that'll be my happy thing.
Nice.
That was really enjoyable to see them do that.
I like that. That's a good one.
Well, thanks, Jam, for coming and for sharing your kids with me, first of all. And second of all, for letting me come over and teach you all about the chemistry of butter. And thanks to Clarissa for asking that question. That was a really good one. And I had so much fun learning about the chemistry of butter.
Yes. And thank you for teaching us. And thanks again, Clarissa, for asking it. And if you have an idea or question or thought that strikes you that you're like, I wonder if this is chemistry. One, it probably is.
Probably is.
But at least some part of it probably is chemistry. But we'd love to hear from you. So please reach out to us if you have a question or idea on our website at chemforyourlife.com. That's chem, FORyourlife.com to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to patreon.com/chemforyourlife or tap the link in our show notes or the description to join our super cool community of patrons. If you're not able to do that, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson, and Jam Robinson is our producer. This episode was made possible by our financial supporters over on Patreon, and it means so much to us that you want to help make chemistry accessible to even more people. Those supporters are Avishai B., Bri M., Brian K., Chris and Claire S., Chelsea B., Derek L., Emerson W., Hunter R., Jacob T., Kristina G., Lynn S., Melissa P., Nicole C., Stephen B., Shadow, Timothy P., and Venus R. Thank you again for everything you all do to make Chemistry for Your Life happen.
And if you'd like to learn more about today's chemistry lesson, check out the references for this episode in our show notes or in the description.
Yay, chemistry!